In this video, I will give you a short overview of SmartPy. We will talk about its history and goals, different uses of SmartPy, its online IDE, and about metaprogramming. So SmartPy was a project that was started in 2019 with a number of goals. The idea was to make it possible to write Tezos smart contracts in Python, or we should say in a language that resembles Python and is easy to use for Python developers. Another goal was to make metaprogramming available. SmartPy programs are programs that generate smart contracts, and the same program can be used to generate multiple versions of a contract. Finally, a goal was to support the complete life cycle of a contract, from editing your smart contract to exploring it once it's been deployed on the blockchain. Initially, SmartPy was focused on the browser with an online IDE, and more recently, command line tools have also been made available. SmartPy supports all of Tezos features, including the latest features such as tickets or metadata. And if necessary, you can always include Michelson code directly within SmartPy. The current team is composed of 5 regular contributors. Many contracts, among the most used on Tezos, were developed using SmartPy. For example, Hicket that manages decentralized digital assets such as pieces of art or music, Harbinger or Chainlinks that are price oracles, Colibri, a stablecoin with collateral, project like TZ Colors, Logical Pictures that manage the rights of movies and TV shows, and Société Générale Forge that handles the emission of a structured financial product as a security token. You can check this link for up-to-date information about projects based on SmartPy. One of the key aspects of SmartPy is the online IDE that it offers, that works directly in your browser and covers all of the steps of the life cycle of a contract. So you can develop your whole contract directly in your browser, from the edition of your contract, accessing the documentation, compilation, testing, deployment, and even exploration once your contract has been deployed on the blockchain. You can test it at this address. So this is what it looks like. On the left side, you can edit your contract with the contract itself and all the code for testing this contract with different test scenarios. And on the right side, you can have the output. For example, you can run this code and you get a visual presentation of this execution and the result of applying all the different test cases. And from the same interface, you can deploy your smart contract, explore it, analyze it, and access to the documentation. When you program in SmartPy, you're actually doing metaprogramming. So a contract in SmartPy is built during the execution of the Python script. You don't actually write a contract, you write code that generates a contract. So the Python script is executed, it produces an abstract syntax tree, which is then converted to SmartML, a language based on OCaml, and then converted into Michelson. And finally, the Michelson contract itself runs on the blockchain or in the simulator. And so metaprogramming can be useful, for example, if you want to generate multiple versions of a contract. Here is a small example where you have a contract with a section that depends on a value, and depending on this value, if this is true, then this entry point will be added to the contract. If not, this feature won't be available in the contract. So you can write code that, depending on a number of options, will generate a number of different types of contracts based on the same code. If you want to learn more about SmartPy, here are a few links to the smartpy.io website, the community on Telegram or Stack Exchange. You can also follow SmartPy on Twitter or on Medium.